Okay, now we're going to do some examples with composing functions. So we're going to look at these two functions. F of x equals 2x minus 5, and g of x equals x plus 5 over 2. And we're going to start out by doing f composed with g of x. So remember, if you want to start with the first one, write that function out. So we're going to take f of x, 2x minus 5, and write it out with parentheses where the x is. So 2 parentheses minus 5. Now we're going to plug in g of x where those parentheses are. So that would be x plus 5 over 2. And now we want to simplify this. Now the first thing we can see is that here this is like 2 over 1. So we have this 2 in the numerator, 2 in the denominator. Those are going to cancel out. So we have x plus 5 minus 5. And we know that plus 5 and minus 5 is 0. So we just get x. Now what this is actually saying a pretty cool thing, is that for this function that we call f composed with g of x, when we put in x, we get out x. Meaning if we put in 2, it would go into this machine, it would spit out 2. If we put in 3, it would go into the machine, spit out 3. Okay, now what is that kind of saying with our f and our g? Well, first it's going into g. First it's going into the second one. So we're saying first we take x, we put it into g, and that spits out g of x, which we know isn't just the same as x, right? It's doing x plus 5 over 2. So for example, if we put in 1, it's spitting out 3, because if you did 1 plus 5, that would be 6. Divided by 2 is 3. Now we're putting 3 into f of x. Well, that machine is 2x minus 5. So if we put 3 into 2x minus 5, we get 6 minus 5 is 1. So what we're kind of saying is that f is undoing g. Okay, whatever g did to our number, change it to a different number, f is always going to change it back to what we originally plugged it into g. Okay, let's get rid of a little bit of this. And let's look at g composed with f of x. So here, since g's first, we're going to write out g with parentheses where the x is. So x plus 5 over 2. And now where those parentheses for x were, we're going to put in f, 2x minus 5. To be honest, here those parentheses aren't, changing anything for us, so we can just write it as 2x minus 5 plus 5 over 2. So first we're going to look at the numerator and say minus 5 plus 5. Well, that just becomes 0. So we have 2x over 2. The 2's cancel each other out, and we just get x. So this is actually the same thing happening, even though we reversed. First we put it into first we put it into f, and then we put it into g, and g undid f. And there's actually something really special going on here, and you're going to have to try to think of functions that work like this at the end of your lab, and you might see that it's not as easy as you might think. But these two functions are called inverses of each other, because they inverse what the original function did, and we'll talk about them more later in the class, but it's just nice to be aware. So we might want to ask a question: does f composed with g of x usually equal g composed with f? Does the order matter? And the answer is normally they do not equal each other. Normally they do not. So this is another way of saying that the order does matter. Okay, so you may not be believing me too much right now, because the example we just saw that didn't happen. So let's look at one more example. Let's look at f of x equals 3x squared plus 1, and g of x equals 4x minus 2. And let's do it both ways. Let's do f composed with g of x and g composed with f of x. So f composed with g, this is more good practice. We're going to start with f and put parentheses. So that this is an x squared, so we're going to put parentheses squared plus 1. And in our parentheses, we're going to put 4x minus 2. Now, what does this mean when we simplify it? It means we're going to have 3. And then what does 4x minus 2 squared mean? It means 4x minus 2 times 4x minus 2 plus 1. Now, like you've seen a lot already in this section, we're going to have to FOIL these. So I'm going to start parentheses, and we're going to FOIL 4x minus 2 times 4x minus 2. So we do 4x times 4x, so that's 16x squared. Outside 4 times negative 2, so 4x times negative 2 gives us negative 8x. The inside also gives us negative 8x. And the last one's negative 2 times negative 2 gives us plus 4. And then we have this plus 1 at the very end. Okay, now we need to distribute this 3. So 3 times 16 is 48. So we're going to have 48x squared. Then we want to do 3 times negative 8x, so that's minus 24x. 3 times the negative 8x, so minus 24x. And the 3 times the plus 4, so that gives us plus 12. And then we have just this plus 1 by itself. And finally, our last step, combining like terms. We just have, there should be a minus here, we just have 48x squared. And then minus 24x gives us negative 48x. And then we have 12 plus 1, so plus 13. Okay, so here what we're saying is that for these two functions, f composed with g of x is equal to 48x squared minus 48x plus 13. Now let's do it the other way. Let's go ahead and do g composed with f of x. So that means we're going to start with g and write it out as 4, leave parenthesis for x, minus 2, and now we're going to put f in the parentheses, which was 3x squared plus 1. So this one, since the x is the only thing squared, we don't have parentheses, it'll work out much faster. We just need to distribute the 4, so that'll give us 12x squared plus 4 minus 2. And so here, combining like terms, going the other way, we get 12x squared plus 2. So here, g composed with f of x is equal to 12x squared plus 2, which we see is very different from what we got doing f composed with g. So these are not the same, and normally f composed with g does not equal g composed with f.